If you've ever played poker, you've probably heard the term pot odds, but what exactly does this mean and how can you apply it to your game? The truth is, a lot of players misunderstand this topic or misapply it. So today, we're going to take a deep dive into one of poker's most important equations. Pot odds in poker tell you how often you need to win to break even when calling a bet. And this calculation is fundamental to poker theory because it weighs the risk and the reward of calling. So the fundamental goal is to recover at least as much value as you called on average. Sometimes you'll win, sometimes you'll lose, but on average, you want to win at least as much money as you called. So let's put this to the test. This is a button versus big blind single race pot. The button bets 3 chips into a pot of 5.5 chips. What are your pot odds? Take a moment to consider your answer. The answer is B, 26%. Let's reframe the question. Button bets 3 chips into a pot of 5.5. How many chips do you need to win, on average, to justify calling? Well, at least 3 chips, right? That's the size of the call. We want to recover at least 3 chips. 3 chips divided by the size of the new pot equals 26%. So the general equation is simply the amount to call divided by the pot after you call. And this will tell us the required equity, where equity is just a fancy term for how often you'll win. Okay, but why is it called odds, but we're using it as a percentage? Well, you can use either. They both serve a good purpose. To calculate as odds, you simply use the equation reward to risk. Here's an example. You're facing a half pot bet. The risk is half a pot, and the reward is your opponent's bet plus the pot, 1.5. You're getting 1.5 to half or 3 to 1, which is just a fancy way of saying that the reward is 3 times greater than the risk. Now, tricky question. If you're getting 3 to 1 in a bet, how much equity do you need to call? Take a second to consider your answer. The answer is B, 25%. If you guessed C, this is a very common mistake. It's not 1 divided by 3, it's 1 divided by 3 plus 1. The general equation is risk divided by risk plus reward. That's how you convert a risk-reward calculation into an equity equation. So you need to win 25% of the new pot in order to justify calling. Generally speaking, you can calculate pot odds as odds or equity. Odds are better for comparing risk-reward. Equity is better for calculating how often you need to win. So in this chart, I've shown the bet size on the left-hand side, the pot odds, and the required equity. You don't necessarily need to do math. You can just get a chart like this and kind of memorize some numbers to have a feeling of how it changes. Let's ask ourselves an interesting question. How do pot odds scale against an increasing bet size? Here I've graphed the pot odds against the bet size expressed as a percentage of the pot. And you can see that as the bet gets larger and larger, you need more and more equity. But something interesting happens as the bet gets bigger and bigger and bigger. 2x pot, 3x, 4x pot. You can see it tends to flatten out. The required equity is kind of stabilizing. And what's happening here is it's approaching an asymptote at 50%. You can't bet a size that's going to force a hand that's ahead of your betting range to fold. And that's what having more than 50% equity would mean. I also noticed that the slope of the curve is much steeper between the 0 to pot-sized betting range. And that's why these sizes are typically more common in poker theory, because you get more bang for your buck, so to speak. That is to say, you can raise the required equity to call while donating less chips to the pot. Don't get me wrong, overbets are still common in theory, but more so in very polarized situations. All right, let's try pot odds facing a raise. So button bets 3 into a pot of 5.5, and this time a big blind shoves 18 chips. How much equity does button need to call? Take a moment to consider your answer. The answer is A, 36%. So again, to calculate the required equity to call, you simply use the amount to call divided by the pot after you call. In that case, it comes out to 15 over 41.5, which means you need 36% equity to call this shove on the button. Okay, so let's put this in practice. Let's say that the button holds king, queen of clubs. So they've got the nut flush draw, and we suspect that big blind is shoving with top pair, for example. What you can do as a simple exercise is count your outs and multiply your outs by 4. There are 9 club outs. We assume all of them are good. In that case, 9 times 4 is 36%, using the rule of 2 and 4. And therefore, our king, queen of clubs has about 36% equity, which is exactly what we need. And if the big blind is bluffing at any frequency, for example, with a worse flush draw, then we have more than enough equity. So yeah, you should probably make this call. Next, I want to talk about how pot odds affect your bet construction on the river. So in this graph, I've shown the bet size as a percentage of the pots on the left-hand side, your pot odds, or required equity to call, in the second column, and on the right column, we see value to bluff construction. And you'll notice that you can use more bluffs with a larger bet, and you need to use fewer bluffs with a smaller bet. What's the reason for this? Well, it's because when you bet larger, your opponent needs more equity to call. And if you're betting a nuts or bluff, a polarized range, you need to be bluffing at the same frequency as the pot odds you're laying. So, for example, for a pot-sized bet, your opponent needs 33% equity to call, and therefore, you should be bluffing overall a third of the time. And the reason for that is that you want to make your opponent indifferent between calling and folding their bluff catchers. If you're under bluffing, they can just always fold and then your value doesn't get paid off. And if you're over bluffing, they can always call and extract value from you using too many bluffs. And so the size of the bet influences optimal river value to bluff construction. I should note, however, that this doesn't hold for earlier streets. In fact, it compounds on turn and compounds even more on the flop. You can bluff more often on the turn and even more often on the flop, and this is due to a concept called leverage. I'll link an article down below to explain that concept further. All right, so let's try to apply the concept of pot odds to a pre-flop spot. Here I've got a standard button opening range. Button opens 2.5 chips into a pot of 1.5. It folds to the big blind. The required equity is 1.5, that's how much big blind needs to call, divided by 5.5, meaning that we should call with hands that have 27% equity. Right? Right? Not quite. So here's big blind's equity facing this button opening range. And if you look at the numbers, every single hand in big blind's range has pot odds to call. Even 7-2 offsuit with about 30% equity, or 29.92, has correct odds to call. But this should be setting off alarm bells because this is a terrible call. So even if we look at this in GTO Wizard, we can see that calling, raising, doing anything other than folding is just setting money on fire with this hand. And clearly just calling all of your hands is not a good strategy. So why is this? Well, back in the day, people used to open 4x, 3.5x, because they calculated this exact same thing. They said, if I don't open large enough, then I'm not laying the right odds. And solvers came along and they showed, no, you don't have to lay the right odds this straight, because if they call too wide, you can punish them on later straights. And this gets to some fundamental limitations of pot odds in the sense that we typically use it. The pot odds equation is sound, to be clear, but equity, this concept of how often a hand will win, this is not sound, because raw equity doesn't correctly predict value when future bets can occur. It doesn't consider actions on later straights. Equity, as we've seen in that previous graph, just thinks how often will the hand win when it's checked down. It doesn't consider all of the future bets that can happen, times where you get forced off your hand or when more money flies in. It just assumes that 7-2 is going to win 30% of the time, but that's not the case. It's going to win way less than 30% of the pot. So when future bets can occur, there's a fundamental limitation on pot odds. However, if we replaced raw equity with something we can call true equity, then pot odds becomes correct. And there's been a number of attempts to calculate the true value of a hand, and we can call this the EV, or expected value of a hand. At first, we built a concept of implied odds, that is to say, value that comes in on later streets. And people built extensive models and spreadsheets trying to map out implied odds. But as technology developed and solvers came along, we invented this term equity realization, which is just a factor between the raw equity and the actual value of a hand within a GTO solution. So let's touch on these topics a bit and see how you can apply them to your game. Starting with implied odds. Implied odds are the money you expect to win on future streets, for example, when you outdraw your opponent and win extra money. Reverse implied odds also exist, so this is money you expect to lose on future streets, for example, when you outdraw and lose anyway. Let me give you an example. Let's say we're drawing to a club flush on the turn. We're facing some turn bet, we've got a flush draw, we call. We can make extra money on the river when our opponent bets, or for example, we can bet the river when we hit, but we incur no extra loss beyond our turn call when we miss. And therefore, we can say that future profits decrease the required equity to call. This is because we're making more money when we hit and losing less when we miss. Here we can see the expected value of a club flush draw on the river, and obviously it's going to be much higher when you hit, and you can get more money in this case and don't have to put more money in when you miss. Reverse implied odds also exist. So you could make the flush draw and then lose to a better flush and get stacked. This also happens. And solvers are very, very sensitive to implied and reverse implied odds, particularly in deep stack scenarios or 100 big blind cash games, for example. They're very sensitive to implied odds. What about equity realization? Well, your true equity is the actual pot share you expect to win given all the post-flop variables. Equity realization is a factor that goes in between your equity and your expected value. So here's one equation for it, but a more intuitive equation is just your EV pot share, so what percentage of the pot will you actually win, divided by your equity pot share. How often would you win if it were checked down? And so equity realization is great because it tells you how well a hand performs relative to this static check down equity. An equity realization factor greater than 1 indicates a hand is over-realizing its equity. Less than 1 means it's under-realizing its equity. Fundamentally, this is really handy for learning which hands benefit from building a pot and which hands, given the option, would prefer to just check it down if they could. Not always, they can't always do that, of course, but it gives you an idea of the incentives and the performance of different hands in your range. Let's put theory into practice using a GTO wizard example. So cutoff opens 2.3, and we face a 3-bet from the button, and we call. The flop comes King 9-6 two-tone. So first of all, let's examine the equity realization. I'm going to select the ranges tab, so I can compare both players' ranges at the same time. We'll go full screen, and I'm going to select EQR from both of these dropdowns. Now remember, an equity realization of greater than 100% means that those hands would win more than if they were checked down. And you can see that most hands in the button's range are over-realizing their equity, and this is due to their overwhelming positional and equity advantage. Meanwhile, on the cutoff side of things, most of their range is under-realizing their equity. And so the cutoff is going to struggle immensely here. And that's shown here in the EQR section. We can see that the button has more equity, more expected value, and will realize more of that equity. But which hands realize equity more? Well, for example, if we just take a look at, let's say, 10-8, you can see that most of these 10-8 are not doing so well. They're only realizing about 40 to 60% of their equity. But 10-8 of hearts with the flush draw is going to be much better. And that's because this hand has better implied odds and it can win more value. So 10-8 is quite a valuable hand here if you have a flush draw. Not so much without. So draws tend to over-realize equity. Similarly, nutted hands tend to over-realize equity, especially if your opponent is in a position where they should act aggressively. So pocket sixes, in the cutoff's case, it's going to win way more than it would if the pot were checked down. All right, so let's go back to the hand here. We check to the aggressor, and they range bet. And you can see it uses something like a 20%, 33% pot size bet. I'll choose the 33%. Now, facing this bet, how much equity do we need? Well, if you calculate your pot odds, you'll find you need about 20% equity. Let's think about this. Which hands in our range have 20% equity? I'm going to use the breakdown tab. And the reason I'm using this is because it has this all combo summary at the bottom, which displays the equity of your hands and the strategy of your hands. So we're sorted by the weakest hands here to the strongest hands on the right. And we can see some interesting stuff going on. So for example, up here, pocket eights is folding. And I'm going to click all over here, and this will display the equity of this hand. We can see it has 39% equity. That's a lot of equity. And we only needed 20%, so why is this hand folding? Well, we take a look over here, we can see Jack 10 only has 25% equity, but it's always continuing. And the reason for this is implied odds. Jack 10 is a draw to the nuts, whereas pocket eights is, especially pocket eights without a heart, is really doing badly. At best, you can hit a set and half of your sets complete flush draws. Not a fun situation to be in. Conversely, if we look at something like this, let's say ace of hearts, jack of diamonds, well, you've got an overcard to the king, backdoor flush draw, backdoor straight draw, and importantly, you can hit top pair without completing those flush draws. And so these things all impact how much value your hand will generate on later streets. So raw equity isn't really an appropriate factor here. Rather, we want to anticipate the actual value of our hand. All right, so let's go on with the example. We call. The turn is the two of spades. We check. Our opponent bets, let's say 75% pot. And we call. And let's say we get an eight of spades river. We check. The opponent shoves just about full pot. Action's back on us. Now let's take a look at the ranges tab. Here, I want to take a look at this equity graph. This displays every combination in both players' range. This blue line shows the cutoff's range, and this green line shows the button's range. And here we can see the button's value and the button's bluffs, and they're polarized, right? They have strong hands and they have weak hands. And we have bluff catchers, mostly. Notice something interesting about the bluff catchers. It's a long, flat line where everything has approximately 33% equity, give or take. And the reason for this is that the solver is balanced. For a pot-sized bet, how much equity do you need? Well, you need 33% equity facing this bet in order to call. And so these hands that are indifferent, like ace-9, ace-queen, should all have about 33% equity. And similarly, button should be bluffing about a third of the time, which is pretty much exactly what they're doing. And so you can see pot odds becomes much stronger if you're using equity as opposed to the true value of a hand on the river, simply because ranges are more polarized. And when you look at previous straights and earlier straights, we're more concerned with things like how can we outdraw our opponent's value range? Which hands are going to perform better? And what's the true value of this hand rather than what is the check down equity of this hand? For further info, check out the articles I've linked below. If you want to learn how to use pot odds to optimize stack-off ranges, how to calculate the EV of calling, or how to derive the pot odds formula using expected value, or even determine optimal river bluffing frequencies, all of that can be done with pot odds. It's a really useful equation despite its limitations. So check out that article if you'd like to learn more. Let's summarize. Pot odds compare the risk of calling to the reward of winning. Fundamentally, if the bet is $5, you need to win at least $5 back on average. And in order to calculate how often you'll need to win that new pot, for example, what you do is you say, how much do I need to call, and divide that by the pot after you call. The thing is that raw equity, or required equity, ignores action on future streets. And so things like implied odds, equity realization, and these post-flop variables can all affect the true equity of a hand. If you have any questions, check out our Discord server or drop a comment in the YouTube section down below. Anyway, that's my video, guys. Hope you enjoyed it. Hope you got something out of it. If you want to see more beginner level content like this, let me know. And as always, happy grinding.